These are the important function in any industry. There are different functions like sales and marketing, design, manufacturing, HR, IR, finance, accounting, industrial engineering, maintenance, and supply chain is a major function which is consolidating from end to end, from customer voice to delivery. Then why we are going to have a key performance indicators for any functional industry? These key performance indicators, these are of three bases, three on the basis of three grounds. That is the individual key performance indicators. Then there are the functional and the organizational. As per the name, it is clearly revealing the individual means individual employee is performing, and the functional is the functional together in an industry, and overall industry जो top parameters होते हैं, that is the overall functional performance. Sometimes we want to know why these are depending upon the individual functional organization, because individual when we are performing as an individual and not getting the results from the organization or from the function as per the individual performing, then we have a different questions. And same with the function and organization. Sometimes organization achieved or not achieved, but the people are being paid or for the performance, for their salaries and all that. And simply the functional targets met, but individual is performing or not. That is also a criteria. This is also the mapping has to be done for the key performance area from individual to organization, and vice versa, from organization to function to individual. This is the alignment of critical success factors. I'm using the terminology differently. Key performance indicators, measure of performance, and critical success factors. These three all words are synonyms, and these are used by the different industry for the different people, where the weightage of the key performance indicators in the industry is depending upon the different industries. But majorly I had covered depending upon the last 25 years of experience with the different OEMs or tier 1 or tier 2 industries. The organizational key performance or critical success factor having a weightage of almost 30% in the success factors, and 30% functional parameters are being defined on the weightage basis, and individual performance is considering the 40% of the weightage. Then the key performance indicators can be defined on the basis of three basic functions or three basic parameters. Hello. Hello.
I think so. Continue, Sandeep. I think it was something.
Yeah, the classification of key performance indicators depends upon the industry for the base of customers, then the financial, and the third one is the process. Customer means you have to address the customer delight, then the financials, that profit has to be earned for any industry, and the process, that is the manufacturing and the internal process of the any organization. The reason of this basis or classification is the industry work for. The basic objective of the any industry, it is for to achieve a top line and bottom line. Top line means what the target is for any industry. Like we have to achieve so much of value of sales turnover, or we have to achieve the profit of this one. And bottom line is what is our profit of after tax, after all liabilities and all that. These two are the basic objectives of any industry for which any organization or any one work for. Out of these industry, there are three parameters, which is a input, process, and output. Input means management and investment, which is the top line, which drives the top line. Process means functions which is depending upon the key performance indicator, that is KPIs, measure of performance and critical success factors. And output is a net line, that a profit. We will cover the majorly the supply chain functions, key performance indicators, which is basically top 10 I had tried to cover, OTIF or OTD. I'll explain one by one in the next upcoming slides. Then sale plan adherence. What is a sale plan adherence? Then the manufacturing loss. Then RMC means raw material cost. Except to this raw material cost, a consumable cost and indirect cost is also contributing to the profit and supply chain key performance indicators. Then inventory turnover ratio, inventory aging, cash flow, cost reduction, and de-risking. I think most of the people are from the industry, so I don't need not to explain the detail in this slide. One by one in next upcoming slides I will share. This is the OTIF and OTT, which is a customer oriented key performance indicator, which means on time in full, on time delivery, sales plan adherence. These are the customer oriented key performance indicators. Means you have to deliver the goods or the objective to the customer in full or in time, and whatever the sale plan of the organization is there, that has to be adhered as per the plan. Then the second one is the manufacturing loss. This is covering the capacity, man hours and overheads. This is part of covering of plant operations and process, that capacity of the plant to be utilized at the utmost without any loss of man hours, and it has to it has to completed this capacity and man hours has to be completed within minimum overheads. Next is RMC and consumable, which is a financial part of the key performance indicator, which is a raw material cost, logistics cost means handling cost, either it is from internal or outward, and the consumable cost. Then indirect cost is there, which is a power, utility and administration cost. Then the cost reduction and cash flow, these are the financial parts for which the cost reductions can be done by zero-based principal costing, alternate sourcings, then value analysis, value engineering or value stream mapping. Then cash flow means you have to, as a supply chain professional, one has to understand the payment cycle from procurement to pay and sales to recovery. That has to be aligned. Mostly in the industry, it is almost 90 days. Then the inventory and de-risking. Inventory is a financial come process. Inventory is a cash which is a company carrying, either it is in terms of in process or manufacturing or in finished goods. Or inventory aging, it has to be aging of the inventory which is lying over there as per the number of days, which needs to be minimized. Inventory turnover ratio and inventory aging, these are the vice versa. Inventory turnover ratio has to be maximized in any industry, and inventory aging has to be minimized. De-risking of the supply chain is essential in last financial years, because strategic sourcing through the legal contract and agreement, it de-risks the suppliers and the raw material constraints and process also. Then in the last years and some years, discipline, ethics and behavior becomes a major part of the industry to give a performance indicators to any of the employee. In discipline ethics, this is the time commitments, integrity, dependability and reliability, behavioral, walk the talk, trust, empathy and transparency. In discipline ethics, time commitments doesn't mean that everything has to be in or out timings and all that. It is depending upon the time commitments to your tasks. Integrity means how you behave in the industry and with the other external parties and all that. That is a major part of the supply chain, which is a major contributor for any person to go on the future long-term relationship with the industry as well as external agencies. Dependability and reliability, the company or the function or the your immediate superior, either you can rely he can rely on you or not. Then in behavioral part, it is a walk the talk, means what you say, what you do. Trust means you are trustworthy for the company to give on any assignment and all that. And empathy means you understand the behavior of the your team, your boss, and your working associates. Transparency means the communication, how you communicate with the upper management, with the lower management, and how the objective of the company is drilled down to the team through you. That is a transparency. So these are the major key performance indicators and critical success factor for an employee or for any function or in any industry. So I think I have taken 15 minutes. Any questions regarding this? Welcome.
Sandeep,
Any
what is the
question? Yes.
Sandeep, what is the difference between OTIF and OTD?
OTD is related to timely delivery of the. If you go through this, I'll show you. OTD is on time delivery. That is in different industry for the small components, for retail components, they may be made available ready for the customer. And sometimes the long lead items like for the plants, big plants, sugar industries and all that, some components are there. So there is a timely limit or the delay clause is there. LD clause is there. So timely delivery is a part of some in some of the industry on time full is considered as a KPI, or some in some of the industries on time delivery is considered as a KPI. So it may be varying from industry to industry.
Okay.
I have two questions, Sandeep.
Yeah.
This is Rajesh Chaudhary. First
Yes.
of all, thank you very much. I think I am from the sales side, so very good overview for me for supply chain KPI. So my first question is, how do you define inventory turnover ratio?
Okay.
And similarly, the second one is inventory aging.
So I'll explain you in detail. For inventory turnover ratio, it's a closing inventory of at any point of time. You can say it's a closing inventory at the opening of the month or the at opening of the month or closing of the month
Mhm.
with respect to the sale done for the month. Or you may be defined in the current scenario at any point of time sale with respect to the closing inventory.
So inventory will be calculated at the cost or at selling price?
No, it will be at the standard cost. It will
Standard
be,
cost.
yeah,
Okay.
it will be a standard cost. Sometimes the company used to run the standard cost once in a financial year, and sometimes they used to run in quarterly also. So it is
Okay.
a standard cost of the product which is lying in the inventory. Sale
Right.
is the revenue part.
Right. Now it's clear to me.
Okay.
And what
And the
about inventory aging?
inventory aging is the inventory which is lying for more than 30 days, more than 60 days. Like one product is lying with you for 100 rupees for more than 30 days. It is a cash lying with you without any rotation.
Okay.
So it
Okay.
should be minimum. The inventory
Okay.
aging should be minimum.
Okay. By number of days or number of months,
Yeah,
basically.
normally more than 30 days inventory is not good in a regular industry in OEMs
Okay.
and all that. So
Okay.
right now we are talking about the JIT and Kanban system where the daily inventory is being rotated on. So that is a good part of that. And inventory turnover ratio has to be maximum in any industry. Normally in the automobile industry, it is almost more than 42 inventory turnover ratio.
Right. Thank you. Thank you, Sandeep.
Yeah.
Sandeepji, the terminology, although I am not from this related field,
Yeah.
but since I have worked in parts department, what we call stock turn, inventory turnover ratio and stock turn is one and the same thing, I suppose?
Yes, sir. You can say inventory turnover ratio is in the this is a terminology used in the manufacturing one, and stock turn is for the warehousing sections.
Okay, right. Thank you.
Yeah.
Sandeep ji, this is Vivek.
Yes, sir.
Good to see that a lot of weightage is given to customer satisfaction or customer delight.
Yeah.
I'm also in sales for a long time, and we find there is a gap in what we present and what is the actual place. So, how do you get? Do you have a regular connection with your sales team, or how it is? How you come to know? Because customer think sometimes if depending on the product, it keeps changing from order to order or something. So how do you dynamically keep track of that you are meeting the customer
Actually, in
demands?
the conventional modes, earlier what used to be there, the sales plan used to come once in a month, and that is with the confirm rolling plan for the month and 2 months tentative. But nowadays, the market dynamics has been changed. The daily sales plan is coming, daily planning, manufacturing and planning has been done as per the customer requirement on the priority basis, and the utilization of the plant capacity has to be aligned with the sales demand also. So the sales and operations team has a very close monitoring with the supply chain team, or the supply chain person is closely monitored with the sales operational team to meet the requirement as per the customer demand. It is not like that whatever is convenient for the manufacturing, for the industry, that has to be produced irrespective of the sales team. It has to be aligned, the manufacturing and delivery has to be aligned as per the customer, which is being taken care by the sales team. That's why the sales and operations nowadays is being done on the weekly basis.
So I would just like to ask that whatever KRA, on different, tasks to be performed, like releasing the PO on vendor and on, whatnot. So do you have a timeline defined, whether if you do it in that much timeline, so
Yes,
you meet the
depending.
target, and if not,
Yes, yes.
then
I'll tell you in brief in sales plan adherence. I have mentioned the sale plan adherence as a customer point of view in this. Sale plan adherence can be done in 3 ways. One is I am having a plan of 100 rupees in a month. I can manufacture anything and I can sell anything. By end of the month, it should be 100 rupees. Then the sale plan adherence is there. But nowadays, it is not like that. It is depending upon what the customer had ordered, what the time period has been given. Accordingly, the weekly delivery or daily delivery has to be aligned. It has to be not on monthly basis or the value basis. It has to be line wise, value wise, and time wise. And the second question, what you have asked, can you repeat that one?
yeah, I mean the targets what you have, various tasks are there. So how do you define the targets in view of the customer requirements?
It is depending upon the
That task
number
is
of line.
performed to be
It is a sale plan adherence
line
as per
items.
the
Okay.
line items and value wise.
Okay.
Yeah, it is a customer
Thank
order
you.
wise.
Thank
It is
you.
not like that. If one item has been ordered by the 3 customers, then accordingly 3 customers has to be fulfilled by their quantities within the time period and as per their target times.
Thank you, sir. Thank you.
Sandeep ji, Nikhil here. I'm
Yeah.
having one query.
Yes, sir.
As you may be knowing that there are some agriculture reforms going on in the India.
Yeah.
And how do you see this, that in agriculture sector, what are the key issue related to supply chain management, or what do you think these reforms will be helpful in managing the supply chain management, or they will be having no effect on the supply chain management? How did you see these reforms?
Sir, I think supply chain management in the agricultural is being managed very well as on date, and whatever the reforms are there, it will be very early to say it will not have any effect or will have any effect, because what kind of the agreements are being going on, whatever the government's policies are being going on, till the time it is not been implemented, because it is partially already implemented in almost 60% of the fiscal locations in India and all that. and most of the areas are covered by that. But even then, I don't think so. Supply chain will be a critical area. It as a critical area, it will be managed.
Okay.
Yeah, because like if you go through this, if I'll take an example of Reliance itself, or I'll go for the Tata products and all that, they are having a good supply chain and logistics facilities and depth approach within the areas, rural and urban areas. So I don't think so. It will be a problem after some reform and all that. Only the financial part will maybe getting affected. Either it will be beneficial for the end user, or maybe some cost may be increased for logistics and all that. But ultimately, supply chain will not get affected.
Thank you, Sandeep ji. Any more question from participant side? So thank you, Sandeep ji, for such a nice presentation. Our next presenter is Gurpreet Singh Gill. Gurpreet Singh ji. संदीप जी आप स्क्रीन अपना ऑफ कर लीजिए ताकि गुरप्रीत सिंह जी शेयर
कर लिया सर मैंने।
ठीक है जी।
Is my screen visible?
हाँ जी स्क्रीन दिखाई दे रही है सर आपकी। Optimizing logistics spend.
Good evening everyone. Just to introduce myself, I am Gurpreet Singh Gill, machine tools, passed out in 1989. So this is about me. Okay, logistic. Why I selected this topic was because this is interesting one, because I came across while working a lot of challenges because I am into sales. So logistic was a main, I would say, area which was a deciding factor for the end price of the product. So generally logistic is, I would say, misunderstood by normal as a layman, I would say. Whereas I would just like to clarify, logistic is nothing but moving resources, could be people, material, inventory, equipment from one location to other at a desired destination. There are two components for logistics: inbound transportation and outbound transportation. For example, any industry which is there, it purchases a lot of components from vendors. So any component or any cost associated with material inward is inbound transportation cost, and outbound is basically when the product is finished and that cost involved for delivering the finished product to the end customer. So this is outbound logistic. And inbound and outbound logistic, the major component which can be a deciding factor is size of the order, destination of the customer, transit damage and loss, and optimum utilization of vehicle. Means optimum utilization of vehicle. When we talk about optimizing logistic cost, so one of the main important factor is how to use the volume as well as load of that particular, I would say, transportation way. For example, if we are hiring a 7-ton of, I would say, a truck, and we are underutilizing it, so probably we have to devise ways and means, which I will be touching in brief about that, how we can use and how to ensure that we use the resources optimally so that we are able to bring down the cost. Reverse logistic. Reverse logistic is nothing but, for example, we are delivering some product to a destination. We have just seen a lot of, I would say, exchange things going on, where a customer returns the material and all that. So reverse logistic comes out when on the onward journey, we are utilizing the transportation for bringing back that material. That is specifically when it comes to this. Also, reverse logistic is also important. For example, if suppose there is a plant in Faridabad and there is another plant in, let's say Mumbai, and we are dispatching certain components and parts manufactured in Faridabad to Mumbai. On the way back, there are certain vendors which are located in Mumbai. And what we can do is we can have a negotiation for F4 Bombay rates, because any component, any manufacturer, if we are asking for delivery at Faridabad, definitely certain value of that cost will be added into the product value. And in the reverse logistic, we will be using the same transport, because in any case, whenever the contract is signed, it is only when the contract is signed, we can definitely use that on the return. Let's say if the truck charges are, let's say, 30,000 from Faridabad to Bombay, whereas on the return, when we are utilizing that, it can be negotiated at 15,000. So that is one way of doing it. Shipment consolidation. This is something like where more than one shipment can be sent together, dispatched together in one particular as one shipment, or also it can be a association of more than one companies for the same destination. Let's say there are maybe two companies who are supplying some components to Mumbai, and the truckload of a particular company A is underutilized. So then this shipment consolidation comes into play. So this can also be used in ensuring that we optimize the cost. Milk run logistic, as the name suggests, so this is nothing but goods are collected by the dispatch on the way. So like, for example, it can be both ways, for purchase as well as for sale. When it comes to purchase, let's say the organization is in Faridabad and the vendor is supplying products from Jaipur, let's say Bawal and Bhiwadi, Gurgaon. So that particular transport mechanism can be used in collecting those components from on the way and delivering it to the plant in Faridabad, so that also it comes it is also true when it comes to supplying I would say specifically spare parts. I would say if the warehouse is located, let's say, in Faridabad, and let's say there is a dealer or a stockist who has placed order, and that stockist is based out in Jaipur, one is based out in Ahmedabad, other is based out in Mumbai, and so on and so forth. But the total capacity of the truck being utilized by one of these stockists or the dealer is underutilized. So what we can do is we can merge those three, I would say, shipments, and as a milk run concept, those can be dispatched, which will definitely bring down the cost. So these three factors are also very important for optimizing the logistic cost. Identifying correct mix. So mix of, in terminology, LTL is called less than truckload, full truckload, or intermodal load. We have to decide out of these how to use them. Less than truckload, as the name suggests, means the capacity of the truck is underutilized. Truckload is optimum utilization of the capacity of the truck. And intermodal, I would say, load is when we use two ways of transportation, let's say from plant to I would say from plant to one location by road, and from that location to other location by rail, and then definitely like it is a container sort of thing. A container is loaded on the truck, then it is being shipped on rails, and then definitely again it is transferred on road, and so on and so forth. So this is very important because we know there is a seasonal variation. There are at time recession, demand fluctuates. So it is very important to ensure that the identifying the correct mode of transportation is selected. Second is tender freight to proper carrier. Generally, we have seen regional carriers. Here, regional carriers, I would say there are two types of carrier. One is national carrier, one is regional carrier. National carrier is, let's say, who operates all India, and maybe where the truck operates from, let's say, Delhi to maybe Kanyakumari. And regional transport, regional carriers are, let's say, restricted to Haryana, restricted to Rajasthan, and so on and so forth. What we have seen, these regional carriers, generally the national carriers, what they do is when they are taking the consignment for on the way back, they wait. There is a sort of, I would say, hub they wait for the next lot of, I would say, load to get, and then probably it is delayed by maybe a couple of days. Whereas the regional, I would say, the regional carriers, what they do is, since they operate within the state or within a defined set of territory, so they don't hesitate in coming back even empty, which is called backhaul, or at a I would say reduced rates. So that is again one strategy which we can use. Optimization of transit days. Here we know at times customer time period is very important for the customer, because he needs the product probably particular on an auspicious day or something like it. And at times we all know, because of supply chain constraint, the end product, the finished product gets delayed, and it is then definitely required that we need to cover up that shortfall by covering the transit days. And here two drivers are generally used, so as to maybe for day and night operation, so that the lead days could be reduced. And and here the advantage is that when the days are reduced with the second driver, then definitely that I would say truck will be free before time, and then definitely that can be used for the next lot also. Invest in proper trolleys, bins and packaging. This is very important, because at times we know there are two types of, I would say, products. One is volume based, one is, I would say, weight based. If suppose proper stacking and trolleys are made, and we use the optimum way how to ship those products, then definitely we will be reducing on that cost, the transit, I would say, transportation cost, and definitely that will have an impact on the end price of the component. Review pricing and contract. This is very important, because in today's scenario, when we negotiate with, I would say, the transporter, what we can do is we can call a tender, negotiate further, and whoever is L1 is the lowest in the tender, should be awarded the contract. And also what is more important is, whenever we finalize a contract, we should finalize keeping in view the diesel prices prevailing as on date. Any fluctuation definitely should have an impact on the price of the transportation or whatever it is. So because majorly the cost involved is diesel in that, and that should be taken as a benchmark. Say, let's say 20,000 is a cost for a destination, and diesel price as of date is X. So there should be a clause that X plus minus 5%, there would be no variation, but anything above that, there has to be some variation. Avoid accessorial charge. Is at times we have seen the customer is very demanding nowadays. Generally, what we have to see in the industry, that should be discouraged, because generally the customer will say it is just 50 kilometers away from the destination where I need the product. That should be avoided, and if at all such things have to be entertained, it should be very clear that cost has to be borne by the customer itself. Generally, what we see is transportation is after effect of production, whereas it should be vice versa. We should produce keeping transportation in mind. It should not happen that the batch size which the production has to produce should keep the endpoint also in mind. Yes, we need to ship this, and what will be the optimum way of shipping to bring down the cost. Transparent working with the freight provider. Probably this I have clarified. What is more important is the quotation should be very clear. The cost of diesel should be there, and it should be very transparent. And also, at times, what can be done is, with the sudden increase in demand, like we have seen post COVID, I would say post lockdown period, most of the automobile and earth moving equipment, the demand has suddenly increased. Vendors are not able to supply. There is a shortage of, I would say, the transport vehicles. So here, what can be done is, since they will be getting the additional business, all the transporter companies, they at times where their probably trucks were idle for a few days, now they will be fully utilized, or I would say overutilized. Some negotiation has to happen. Now, since it's the time, we have to serve the customer. And also, above all, I would like to mention, Why logistic is very important? Because we have seen there is an increase in steel price to somewhere around 10 rupees per kg. There are only two things: either we increase the price of the component, or we reduce the overheads and definitely keep the price, I would say, same, or maybe whatever minimum is possible to increase, so that it does not have a major hit on the pocket of the customer. Logistic planning again can be described in three ways: vehicle consolidation, inventory consolidation, and terminal consolidation. Vehicle consolidation is clearly maybe two or more shipments can be used in a single truck. Inventory consolidation is definitely maybe we can consolidate the inventory at a stocking point, because like I touched based on that, suppose there is an organization and the parts have to be supplied. So instead of just keeping one mother warehouse, there can be maybe two or three region-wise warehouses. So the material is already stocked there, so that it reduces on the transit day also, and also on the cost. Terminal consolidation is, I would say the latest thing. Here, one terminal is set up, and from that terminal, example I would just like to give. For example, there is an organization in Faridabad who has one more plant in some other part of the country, and the vendor base located is in Faridabad. Let's say there are 10 to 12 vendors who are supplying parts, various components. A terminal hub has to be made where all those vendors will be supplying this product, and then after consolidation from that place, the material is shipped. Because any individual, any vendor does not have a capacity, or I would say the bulk order which by which that full truckload can be used by that. So this is a terminal, I would say, is built up, and then the material is loaded in the vehicles for different locations or destination. So this is in brief about how to make the logistic cost optimum. And here I because of this confidential clause, I am not sharing one practical example, but verbally I will be sharing that. Practically, there was a truck being utilized for shipping a component particularly, and those components were stacked G1, what we say in terminology in logistic, base ground plus one. So any bin which is stacked on the floor of the truck is G, and G plus one is one more bin above that. So those components were shipped to a particular destination, and those were about 6 feet long, and they were placed horizontally. So 12 components used to be accommodated in a truck. So by just changing the orientation of that from horizontal to vertical, I hope one can visualize. When vertically they were placed, I would say bins were placed vertically one above the above, then 20 components were placed. So this resulted in practical saving of 80 lakhs. So this is one example which I thought of verbally discussing with you, because of confidential data, I'm not in a position to show. So that's all from my side. Thank you. Any questions, please?
Any question from audience side?
Gurpreet, Nikhil ji, can I ask?
Yes, sir. Yes, please.
Gurpreet, very nice presentation. Let me appreciate that. I mean, it's very, very informative. Two questions I have. One is, I don't know whether you are from automotive side or not. Have you heard of this packaging, recirculating packaging called CHEF?
Can you be a bit louder? Recirculating?
Packaging
Okay.
called CHEF. There is a company called CHEF. Particularly why I'm bringing this into, because you know that in automotive, we have three main hubs. One is the NCR region, which is one hub. Then second is the Pune hub, and third is the Chennai hub. And there are suppliers who are supplying from NCR to Chennai hub, and there are suppliers who are supplying from Chennai to NCR for Maruti. And what was happening was that you were employing the packaging and then throwing away the packaging at each side, each hub. So have you heard of this?
No, I have not heard of it, but practically what I have, I would like to share the practical example again. What we used to do is from our organization, we were sending some material in bins to a destination in the other part of the country. And what was happening is we were paying for the return truck load for bringing back those empty, I would say, bins. Then finally, what we decided is we started making the collapsible bins. So when we are shipping, let's say example I'm giving 4 trucks, on the way back only 1 truck was carrying that empty bins. So that was I would say new ways of innovative thinking which the team delivered. But practically, I have not heard of the technology what you asked.
Okay, and anyway, that's the concept which I was wanting you to talk about,
Yeah.
which was the collapsible packaging and
Right.
recirculating type packaging, wherein you can save lot of packaging in terms of environmental advantage you get, and also it is a financial saving. So that was one part. Anyway, you are practicing that. The second question was on the zero-based costing for your truckload. Now, have you developed some sort of a format, though you have identified the components of, for example, diesel cost, you've said about weight volume ratio, and of course, you would have taken depreciation also into consideration while you were doing costing for the truckload. Have you developed any format for that, which will help to analyze the different truck operators so that you are able to take a decision on L1?
In fact, what we have done is not specifically because I'm not from that particular department. I'm not handling that. Since I mentioned I am from sales, because of the challenges being faced, so I did this particular project. So I'm not very sure whether it is zero based is being followed or not. But what I know is when it comes to, I would say, negotiation and going in for the L1, that is one mechanism. And then the challenge which we faced is, like say, because these players are very intelligent and very smart players. So let's say L1 is not in a capacity to provide, let's say, X number of trucks per day. So then definitely we have to go to L2, L3 and L4 because we have to serve the customer. So what has been decided is L1 will be the base, and if L2 has to get the order, he has to bring his price at the level of L1. So this is the strategy what we are using. But honestly, zero base, I'm not aware of that since I'm not directly associated with it.
Thank you. That's what I.
Gurpreet, this is Rajesh Chaudhary.
Yes.
First of all, congratulations, very informative presentation. I have only one question that like you dwelled a lot on the transportation by trucks. Do you also, I mean, to what extent do you use a railway as a means of freight?
No, we don't use.
Okay.
In fact, this is one suggestion which I had given, but
Okay.
practically, the kind of equipment which we have, probably the possibility of getting those equipment damaged is high. And railway, we all know, probably. In fact, I had given this suggestion. We can save a lot of, I would say, money if we use railways. So that is one again because we have not got a positive response from anyone because the mechanism and then it's a bit tedious. But once it starts, then probably it will be a success. But yes, definitely, it is in my mind, and I have given this suggestion as well, but not implemented it as of now.
Oh,
Thank
in
you.
addition, in context of that, let me tell you, since I'm right now from railway industry and we are getting a dedicated freight corridor,
Absolutely.
so it's going to be a very lucrative thing for transportation of goods at a cheaper rate. Per kg, you will find it will be much better than the road transport. Worth
I agree with you.
exploring.
I agree with you. But the only problem would be shipment from plant till the probably
To the
railway
railways.
yard or something like that.
Okay.
So, Gurpreet ji, I have one question. This is Praveen here.
Right.
So, since you said that you are from a sales background and you did this project out of necessity, because the challenges you were facing. Yeah. So, have you ever come across a situation where some simulation is required for the transportation process for a goods, like if some new goods are being launched, and how you do the simulation that those goods are not getting damaged in the transportation. And this particularly I'm saying, probably I'm not too sure it's applicable in an Indian scenario or not, but when you have a export scenario and you have to ship your goods to different parts of the world and the road conditions are quite different. So sometimes what happens, some good which is very good in India, because it might not be that good in Africa, for example, if you're exporting it to Africa. So just thought of asking this question in case you have some experience on that.
Just to answer your question, when it comes to export, since ours is quite an old company, so all the processes and these trials definitely would have done probably maybe 20, 30 years ago. And no more, I would say, practical trials are being done because it's established product now. And there is probably hardly any change when it comes to dimension or the weight and all that. But when it comes to exporting, yes, definitely I had the practical experience of exporting, and definitely I did have a good learning about that. What we do is the containers are loaded from the plant, and then they go to Namashiva port in Mumbai, and then definitely. So there are various, I would say, stringent norms. This I came to know probably, let me share, that even you need to have a certificate that it is a non-hazardous, I would say, equipment. What does that mean? Because whenever the machine is produced, definitely it is ignited and it is started for some time for the testing. You need to 100% empty that tank. That is a norm. And definitely it was a surprise to me that a particular plant, we have 2-3 plants, was exempt. For that particular plant, you don't have to give that certificate of hazardous because that diesel comes out to be or different, something like that. So that is something which I had a learning, but definitely specifically having some trials for domestic and all that, we have not done it.
Thank you, sir.
Thank you, Gurpreet ji. Very nice presentation. Thank you. Our next presenter is Praveen Gupta ji.
Okay, thank you, sir. Let me share my screen. Okay, so let me know once you can see my screen.
Yes, it is visible, Gupta ji.
Okay, so first of all, thank you for this opportunity, Dr. Nikhil, to share this presentation of mine with an esteemed group of participants here, which has, I think, hundreds of years of cumulative experience in this forum. So just to give a very quick brief about me, I'm a 1994 batch RAC student, and I have been working into different international assignments in HVAC industry over last 26 years. And I'm currently working with Carrier Air Conditioning as a global director for the product platform management, and based in Dubai. And prior to, and total of my experience out of 26 years, almost 18 years I spent with Carrier. So you can say almost 75% of my career has been with Carrier Air Conditioning, and balance 8 years I spent with Voltas and Hitachi in India. In my career, I have gone through multifaceted functions like product management, sales and marketing, project management, and after sales service. So I can say fairly that I have gone through the complete cycle of field side of the industry. I have not gone into the operations like production or engineering, but as far as the field side is concerned, I have a fair 360-degree view of the industry. So today I choose a topic which is somehow very technical in nature because it is not a general product and being used for specific applications only. So I thought some of you might be from the similar industry. Some of you may not, but I will try to give a very good overview, and then if it interests you, we can have more and more discussion later on. So today I'm going to talk about the chill water. Basically, let me just say, because I'm talking about air conditioning system, central air conditioning system, in which a chill water system is being deployed in multi-story large buildings. So you can imagine large buildings in Delhi NCR region where you cannot deploy a standard air conditioners like what we have in our houses, which is typically a split air conditioners like that. So because you cannot have too many condenser units which we install in our houses all across the building. So we need a centralized plant which supplies the chill water to the whole building, and then we have a dedicated small units at each floor which cools down the air to provide the air conditioning to the occupants. So this is a typical air conditioning system, central air conditioning system it operates. So today I'm going to talk about the optimization methodology being adopted on the plant room, which is the hub of the air conditioning system, central air conditioning system. So it is assumed that roughly around 40 to 60% of the energy of the building is being consumed by the central air conditioning system. So it is a very critical system in terms of power saving and making sure that we have the less use of the energy in the building, and the optimization allows that part. So today we are going to have a discussion around basically these four things which I just mentioned here on this slide, which is life cycle of a chiller plant, chill water plant optimization, heat recovery, and series counterflow chillers. So typically a life cycle of a chiller is constituted of basically three components. One is that when a product is being designed and engineered. Second is when the product is being supplied to a customer. And third is how the chiller is being operated and maintained. So it is very essential to know here that the design cost of a product is just 1% of its life cycle cost. Roughly around 24% of the chiller cost, a central chiller plant, is the cost of the overall part of the life cycle cost. 24% of the chiller cost represents the life cycle cost, and balance 75% is which is being consumed during the operations and maintenance time. So it is very essential that we put up a very specific focus on the larger chunk, which is 75% energy consumed during the operation of the chiller. So all the manufacturers have a very specific focus how they continue to improve the efficiency or the performance of the chiller to consume less power consumption. Each of their design always, like if a product is being designed today and the next product which is going to be launched in 3 to 5 years time, every manufacturer try to make at least that there's a 5 to 10% lower power consumption on the next generation chillers. So that's a typical target everybody keeps. And secondly, because this particular products consume the highest energy, so there are government regulations also, which also mandates that the chilled water plant or chiller plant should not consume more than this much energy per ton, or which is the efficient capacity of the chiller. So they drive certain strategies so that they can also push the industry to develop more and more efficient products. So I will straight away now jump to the plant room optimization. So this is a typical schematic of a chilled water plant room. I have today I will be talking about basically three key components in the plant room. One is the chillers, which is the most power consuming equipment in the plant room. Second is the pumps, the circulating pumps which circulate the water throughout the circuits, throughout the building. And the second set of circulating pumps which are the pumps which are rejecting the inside heat of the building to the atmosphere. So basically in this, if you are able to see my mouse, let me see if I can pick up this thing. Okay, so these are the chillers, which if you can see my mouse, this is the chiller, which is picking up the heat from the inside of the building through this air handling units, which we call. It picks up the heat from the building, and this heat is being transported through the water through this chiller, and then this chiller rejects the heat which has been accumulated from the building through these pumps to the atmosphere using a cooling tower. You might have seen, many of you might have seen the cooling towers, which is a water spraying devices which are running. So they reject all the heat which has been collected from the indoor space to the atmosphere. So this is the broad schematic of the chill water plant. And today my focus area is chillers, cooling towers, and these pumps. So these are three focus area I'm going to talk about today. So the one which is basically highlighted under this blue rectangle. So what happens typically in a chill water plant, that there are specialized consultants or designers who designs the chill water system of a plant room of a building. Customer appoints them, and then he designs the plant room, and then he asks different manufacturers that I need a chiller which should be able to operate at these operating conditions, at these temperatures, and this will be the flow rate, and this is the ambient conditions, ambient temperatures, which is dry bulb temperature and wet bulb temperatures. And then based on these, different people give their submission to the customer. They say they select their equipment, they select the chillers, or the pump manufacturer selects their pump, and or cooling tower manufacturer selects their cooling tower, and then they all submit their reports to the consultant for necessary bidding and then finalization of the contract. So what happens typically, because designer is a third party, equipment manufacturer is one party, pump manufacturer is a second party, and cooling tower manufacturer is a third party. So the sync which is supposed to be happening between all three of them doesn't happen that nicely, because they are all operating on a fixed parameter. Like as a chiller manufacturer, I have been given a certain parameters. I have to select my equipment based on that only. But it doesn't allow the flexibility to me to optimize the performance of my equipment. So which I will talk about with few examples in the next slide. So before that, I will just say, this is another technical term which is called as cooling tower approach. So this term is used for the cooling tower. So it means it indicates the performance of the cooling tower, that how effectively a cooling tower is able to reject the heat to the atmosphere, and which is basically measured using the two parameters. One is the ambient wet bulb temperature and the water temperature of the from the cooling tower. So the difference between the two is called the approach. Means the better the approach, means less the approach, less the delta T between the two. It means the cooling tower is operating at a very good performance level. The larger the delta T between these two parameters, it means its performance is not that great. So what happens? This is the typical design parameters which are being given by a consultant. So he says, I need a 1700 kilowatt cooling capacity chiller operating at 6 and 12 degrees centigrade chill water conditions, and my design ambient is 25 degrees C. So I need a condenser water in and out at 29 and 34 degrees centigrade. So this is a parameter being given to me as a chiller supplier. The similar parameters are being given to a cooling tower manufacturer, because he has to select his tower based on this. And then all of us select our equipment and submit it to the customer. So here is a pitfall. So now every manufacturer has selected the equipment based on this previous design parameters. So what it comes out, a chiller which I selected is consuming 275 kilowatt input power. A cooling tower which has been selected is consuming 20.8 kilowatt. Condenser pump is consuming 25.8 kilowatt. So total kilowatt consumed by the chiller plant, excluding the chill water system, which I'm not talking about today. So the COP, or the efficiency of the plant, becomes 5.29. So this basically 1700 kilowatt divided by 321.6 is a COP. We call it system COP. So this is a standard offer which a designer or consultant would get if we limit us on the design parameters only. Now, if as an alternate way, he allows some flexibility to the manufacturer, that you try to select the best optimized pump, cooling tower, and best optimized chiller, So then how that can be done? So this is one option. Like if we have to optimize it, so my design conditions basic requirement remains same, means he still need the 1700 kilowatt of cooling capacity for the building. Design ambient remains same 25. But if I increase the delta T across my cooling tower, this is the one parameter I'm varying. So what will happen because of this parameter, that my chiller power consumption has changed slightly, cooling tower performance has also changed, pump power has also changed. So in overall, my power consumption has reduced slightly, and my system COP also has improved a little bit. So in this situation, what we have done, we have just increased the delta T of water flow rate across the condenser. Now, next option. So we apply one more alternate. How further can we improve it? So we did the same thing, but in this case, instead of increasing the, we have reduced the condenser water. Sorry, we have reduced the approach of the cooling tower from 4 degrees centigrade to 3 degrees centigrade. So what happens with that change? The rest of the parameters remain same. My power input again changes, and my COP, system COP is 5.4. And then the one more alternate option we applied, where we mixed the option 2 and option 3. We reduce the approach to 3 degrees centigrade, and we increase the condenser water temperature, delta T to 6.7. So with this, again, a set of reading has come, and the power consumption of the system and the COP. So in summary, if we compare all these four, option 1, which was original design, and 3 more options which we have done alternate selections by using the flexibility. So what we realized, the system COP has improved, which means the customer will consume less power during the normal operations. At the same time, some of us maybe think, what about the costing? So costing wise also, if you see the cost part, while option 2 and option 3 are going higher, I'm saying price per kilowatt for a 1700 kilowatt cooling system. But my option 4, which was giving me the best performance as a system, is also cost-wise is also similar to the original design. So which means at the same cost, I'm able to get much better efficiency of the system. So I'm not penalized on the cost part, first cost. At the same time, I'm getting benefit of the running cost. So that's how we are able to improve the system efficiency by having some flexibility in terms of modulating the performance of different components of the plant room and get the best out of it. So this is one optimization technique. So what basically this exercise allows in summary is basically that, as I just mentioned, I think first cost is similar, but the efficiency is better. It allows the consulting engineers to review HVAC system modeling, because normally what modeling is consulting engineer do versus what we have proposed can allow an alternate to the energy modeling. And the system approach, solution approach provides confidence to the customer also. So this is just a part of the presentation where we say client buys peace of mind when they buy coordinated and optimal solutions rather than individual equipment of different performance. So second part on the same on the plant room is that typically what happens in many of the plant room, typically in a hotel industry, you might find that we have chilled water plant, which is for the air conditioning of the hotel. At the same time, we have the boiler plant, which is used for the kitchen purpose, for the laundry, and for various other applications which they use for the hot water. So what they do in the chill water plant, they pick up the heat from the indoor and they reject the heat to the atmosphere to the cooling tower. So basically heat is wasted. Whatever heat we have picked, it is being wasted to the atmosphere by rejection. While in the boiler plant, we are firing a boiler, we are burning the fuel and generating the hot water. So here we are giving the energy, and in the chiller plant, we are rejecting the heat to the atmosphere. So the idea is in the heat recovery, why not we use this heat output for effective utilization for the hot water system? Why we waste it? I'm saying instead of generating fresh one. So typically the COP of a chill water plant is cooling effect over work done by the compressor. And in the boiler plant, the heating COP is heat output oblique how much the work in has been given. So if we transform the wasted heat of the chiller for the beneficial use in boiler plant, it significantly improves our COP, and which is being explained in this slide. So it's the same plant doing the same thing, but apart from the standard chillers which are doing the cooling application, we add a chiller which is called heat reclaim chiller. So what does this chiller do? It produces a high temperature hot water for the system. So while it cools part of the chilled water system, but on the second side, it doesn't reject its heats to the cooling tower. It supplies that high temperature hot water, which is typically around 45 to 50 or 55 depending upon the need, to the boiler cycle. So what it happens when this chiller is providing the heat, we need not to fire the boilers till a time the load of the heating plant or the boiler hot water requirement is much higher than what this heat reclaim chiller can produce. So it significantly saves energy. And in one of our estimate, which we did in one of our plant in US, what we realized that we saved roughly around $100,000 in a year's time by less firing the boilers and rather using the heat reclaim chiller. So it's a significant energy saving and very fast ROI. And this is an example. I just picked up some of the example that for different cooling capacity of chillers, which is mentioned here, which is in kilowatt of cooling capacity. What is the total power input and what is the COP of a chiller, individual chiller. But if we recover the heat on the right hand side from this chiller on the heating capacity, our net COP or next efficiency improves at least by 30% from the standard one to the when we use both sides of the heat. Means at one side we are picking up the heat from the indoor space, and second time instead of rejecting this heat to the atmosphere, we are using beneficially using this heat for the boiler or hot water purposes. So we use both sides of the heat, and then efficiency of the system improves significantly. So basically from application perspective, so it basically what we are saying that we utilize the waste heat which improves in the system performance. It saves the electric power or the fuel for generating the hot water, and then of course it creates a environmentally sound option also, because when you burn the fuel, it adds to the greenhouse gas effects also and create pollution also. And these applications of this kind of system can be any hotel industry, hospital industry, factory and processes, or in some cases where the cold ambient is there, the schools can also use this kind of application. So it has a comparatively wider application where it can be applied. So this was a bit about heat transformation or maybe optimizing the plant room further. And then third technique which we have used, which is called series counterflow chillers, which in a way few of you might be knowing as a cascading chillers. But this is what is series counterflow. So what happens in a chiller plant, you have chillers like this, and you have multiple of these chillers in parallel, one after other. And what they do, at one side, they receive the water from the chilled water from the air handling units, which is inside the building, which is cooling the air. And then it cools down that water to 6.7 degrees centigrade. And then this water is supplied to the air handling units or fan coil units, which again goes to the air handling unit coil and cools down the space and brings it back at 12.2 degrees centigrade. So this is the indoor part of the cycle. Second, 30 degrees centigrade and 35 degrees centigrade is the outdoor part of the chiller. This water goes to the cooling tower, and when after the cooling tower, it cools down and re-enters the chiller at 30 degrees centigrade. So this is the typical cycle operates in a with a chiller. Now this is we call it as a parallel chiller. In the bottom one, we have put two chillers in series. Like here, the two chillers will be in side by side, means both will be receiving 12.2 degrees centigrade water and it will be leaving at 6.7. The second chiller also will be doing the same. But in a series counterflow arrangement, we put two chillers in series in a way that the first chiller receives 12.2 degrees centigrade chilled water. It cools it down. That chilled water cool down temperature enters the second chiller, which is called evaporator portion of the chiller, and then it goes out at 6.7 degrees centigrade. And the opposite side, on the condenser side, it receives the water at 30 degrees centigrade from the cooling tower. It heats up the water, and the same heat of water enters the second chiller and exit at 35 degrees centigrade. So this is called series counterflow when we put two chillers in series arrangement. So what benefit? I'm saying why, okay, before we get into that, so why series counterflow? So some of us from the mechanical batch has already heard about, seen this pH diagram. So basically the performance of a chiller depends upon the
professors and my friends.
So what does this parallel chiller do? I'm saying the refrigerant effect and this heat rejection. So difference between these two, pressure difference between these two is basically what determines the compression work. So if we are able to reduce this, we call it lift in our language, in our terminology. So the higher the lift, the more the power consumption. Lower the lift, less the power consumption. So what happens? The lift is normal in case of a standard chiller, which is arranged in a parallel configuration. And when you put the same chillers in a series counterflow arrangement, the lift, because in one case, the chilled water temperature goes up, and in second case, second chiller, the condensed water temperature goes down. So the lift on a respective chiller reduce like this, like the green portion, which you can see. So one chiller has this lift and second chiller has this lift. So both the chillers have less lift. So and their power consumption reduces significantly. So, and this is the benefit. So ultimate benefit is that we have compared here parallel configuration. LCT stands for leaving condenser water temperature and LET stands for leaving evaporator temperature. And the delta T between the two we call as lift in a general terminology. So you see here the parallel configuration lift is 28.3 in a parallel chiller configuration. But if you put two chillers in series counterflow, so downstream chiller has a lift of 25.8 and the upstream chiller is a lift of 26.1. So upstream chiller is one which receives the chilled water at 12.2 degrees centigrade and the downstream is one which produces a chilled water temperature at 6.7 degrees centigrade. So this is how is being counted as upstream and downstream chiller. So with this reduction, we have a significant saving. On an average, it saves from 7 to 9% of the power consumption versus the same chillers, which when put into series counterflow saves 7 to 9% versus the same chiller put into parallel configuration. So this is very brief. I don't know how much time I took, but I think any questions you might have, I'm ready to answer.
Praveen, thank you very much for this very elaborate presentation, and I really like this. The layman person like me could understand the concept which you have shared, and I really like this series counterflow system which you have talked about, and definitely let me know this concept next time in case I get an opportunity to design a plant.
उपेंद्र जी आपकी आवाज ना क्लियर नहीं है, थोड़ी ब्रेक हो के आ रही है.
Okay, let me try this. All right, any better now?
Yeah, let's try again. Yeah, please.
Yeah, okay. So thank you very much for your this presentation. It has been quite informative, and really like this concept of the series counterflow system. I'm definitely going to use it next time I am given an opportunity to design a plant from scratch. I really like this idea. So I'm very close to this sustainability improvement and all that. So we have worked a lot on this, and we used a couple of dialogues to get it with the and all that. So we should put and all that. Would you please let me know anything, any improvement has been in this year or maglev chillers?
So, Upinder ji, my apologies. I am not able to hear you properly. If anybody else has understood the question, if you can repeat.
Even I am not able to hear.
I
No,
think
we also could not hear him.
it will be better, Upinder.
You can write in the chat box if it is short, sir.
Yeah.
I will just laugh.
Praveen ji, very nice presentation. Although I am having many questions about this presentation because it was very informative, but I'm just asking one or two questions. The first question is that there is some technology in which we are using ice slurry system, and in that what we do, we use the slurry of the ice because it is difficult to flow the ice. In that case, in the the side at which we have to transfer the heat. So we will be using the latent heat of the ice in place of sensible heat. So is this this kind of practical is going on anywhere, or it is just a theoretical concept? Just I wish to know about this.
So what happens, sir? This concept is popular based on the application needs. So in certain projects where for example, the cooling demand is, presume it is 1000 tons of cooling capacity. Now, but your electrical power consumption corresponding to 1000 tons is not available. So the customer may say that my input power which I can supply is only 700 kilowatt, or sorry, 700 tons. So now, but he needs, during the daytime, he needs a cooling capacity of 1000 tons to cool down his building. So in such situation, what we call it, the same concept, it's called thermal energy storage system. So what happens during the daytime, the chiller operates only for power which is equivalent to 700 tons. But in the night time, the chillers operate again when there is no cooling load in the building because there is no occupant, for example, and it runs at -6 degrees centigrade, and it freezes the water in the thermal storage system. So basically, it stores a cooling energy during the night, and during daytime, when you cannot consume more than 700 tons from the chiller, so what you do, you produce 700 kilowatt from the chiller, and you take 300 tons hours or 300 tons of capacity from the stored energy, which is in the form of ice, and it's typically, you can say it's a latent energy, because if you store in a sensible way, the space requirement comparatively may be larger. So in those applications, this ice is being used. We call it thermal energy storage system. So there are ice balls in which there is a special eutectic material made of, and then water is being, so it is frozen. That metal is being frozen by the low water temperature of up to -6, and during daytime, that we pass through the normal water through that and cools down it to close to 6 or 6.5 degrees centigrade as required by the process for cooling in the building. So it's very much popular, but it has limited application because and then second application which comes, for example, in certain areas where government says that during daytime I will charge you 5 rupees an electric unit, but nighttime I will charge you only say 1.5 rupees per unit. So what customer says, okay, I will store the energy in the night because my power consumption will be much lower for producing that cooling effect. So what they do in those applications also, they run the chiller in the night, save the energy in terms of ice, and during daytime they don't run the chiller or very less chiller, and they serve the building through this by melting the ice. So these are the two typical applications where this ice thing is being used.
Vinji, sir has posted the question in the chat box.
Okay, let me just have a look.
I will be reading the question. The question is about the maglev chillers.
Okay.
And they are giving the very high efficiency.
Okay, so Upinderji, the maglev chiller is a technology which I asked the same question to Rajesh Chaudharyji yesterday. So traditional chillers use the oil lubricating bearings. So what happens in oil lubricating bearings? There are two issues. One is that it partially reduces the efficiency of the chiller because this oil also transmits through the whole chiller, and it forms a very light film across the heat exchanger, the tube material, where the heat transfer happens between the refrigerant and the cooling water or flowing water. So, and secondly, it also cause more friction. Still, though we are using the bearings and using the lubrication for oil, but still it has a friction. So the industry evolved, and they say that how we can reduce the friction of the bearing itself so that the torque requirement or the power consumption of the compressor reduce significantly. So then they come up with this technology which is called maglev. It's a magnetic levitation bearings, in which there is no oil being used in the bearing, but they have a very complicated system, which is the bearings are charged and they are floating in the air. In the air, in the sense, means they are not touching the the what you call it?
Magnetic.
Yeah, there's no physical contact between
No
the
physical contact during the operation of the chiller. And
So
those
am I
chillers,
audible now, Praveen?
yeah, you are audible.
No, good.
And
Thank you.
those
Yeah,
chillers
better.
operate at a very high RPM, typically in the range of 50 to 60,000 RPM. And when their RPM becomes high, so your compressor size becomes very small because you can have a high flow rate with the same. But the disadvantage of that technology, because this technology was introduced sometime in 2003, 2004, there were a lot of failures. Initially, almost 6-7 years, the failure rate of the compressor was close to 20%. Though the technology was good, but it was not stabilized because it was not testing in the chill water applications. But then the technology has been stabilized, and it has proved their power consumption or their efficiency is not that, it's almost similar to standard lubricating oil bearing chiller at the full load. But when the chiller operates at the partial load, because your building never operates at the full load, just 1 or 2% of your time building operates at the peak design load. Almost 95% of the time your building operates at the lower loads versus the design one. So these chillers offload themselves and they prove very good performance. But now, having said so, there are alternate technologies available, or even in the oil lubricating bearing, the performance has almost reached similar to the magnetic levitation bearing at much lower cost. But that's a technology, I would say. The key benefit of a magnetic levitation bearing chillers are the starting amperes are extremely low. They operate maybe 2 or 3 amperes as starting current for a very large capacity compressor. And their noise levels are extremely low because the friction is hardly there. So when the chiller operates, the typical noise level of a chiller is in the range of 100 decibels absolute. But for these chillers, the sound level is close to, you can say 80 to 85 decibels only. So it is a significant 10 to 15 decibels sound reduction with these chillers. So these are the two benefits, but the cost of a magnetic levitation bearing is comparatively much higher. So what industry has come up with another type of bearing, which is called ceramic bearings. So again, that doesn't use oil, and it has a performance similar or better than magnetic levitation bearing.
Oh, even better than this.
You can say, for the sake of discussion, we can say at par. Both are at par.
Praveenji, I have a question.
Praveen, for giving the insight on this maglev chiller. I remember way back in 2009, we were suggesting these chillers for a very big plant we were going to set up in Poland by train as well as carrier. So in fact, then we went for the traditional bearing chillers because at that time these were not approved technology. And thank you very much for giving me a current update on this technology. Thank you.
Thank you, sir. You're welcome.
Vinji, what is the life of this one chiller, and who designs it? And is there a customer specific design, or it's already like the material and all those things which are the major part of like component of this chiller? So who designs this chiller, and is a choice of the material, selection material?
Okay. So, sir, the life of these chillers, when it is being designed at engineering level, it is designed for a time span of, you can say, 15 years minimum and 30 years maximum. So that's the typical range in which the chiller is operating. And it's not just years, it also depends on the operating hours. So in commercial, say, office building, the chiller might be operating only for 8 to 10 hours in a day. But in certain application like data center, the chiller has to operate 24 hours round the clock. So it means it is operating 3 times. But in a typical application, it is designed minimum for 15 years. And on an average, the chillers can operate 20 to 25 years comfortably. I have seen the chillers which has operated even for 70 years. So generally speaking, with the routine maintenance being done and everything being taken care of, the life can be anything even more than 30 years. But the challenge why people replace it is because of 2. One is that efficiency standards keeps on changing, and more efficient chillers have been launched in the industry over the last 30 years, which will consume probably 30 or 40% lower power consumption versus that old chiller. Second is the refrigerant regulations, which is being governed by various government in terms of refrigerant regulations, also might have changed. Means the refrigerant which the chillers might have 30 years back it may not be allowed to operate with that refrigerant because of the global warming or ozone depleting potentials. So you have to change that refrigerant. So now the question comes whether you charge a new refrigerant on an old chiller, compatibility check, and second is a performance efficiency. Because as I told you in the beginning, the 75% of the chiller life cycle is in the running cost. So if somebody gets a much better running cost or means performance, so customer prefer to have a new chiller. So typically it doesn't operate that way. Those chillers has the capability to even operate for longer period of time. Like one of the chiller, for example, we designed, the bearing life was almost 5 lakhs hours for that chiller which we used. But chiller will never operate for 5 lakh hours throughout his life. So that's how it is being done.
And regarding the design part, who designs it? It's a manufacturer's choice, or the design is governed by some designer or something?
No, so each manufacturer has its own design, and they work on different technologies in terms of compression, in terms of heat exchanger, and then they simulate. They run the chillers for a couple of years in their labs before they launch. So each manufacturer has its own design, at least a large one, because there is a huge thing or on stake. And when these big players launch their chillers or the equipment, then the small timers, I would say, when I say small timers who cannot spend that kind of money and time to develop a chiller, they simply copy those technologies and develop and they insert it in a new chiller. So the large manufacturers like Carrier, Trane, Johnson Controls, Daikin, they design their chiller. They put a lot of money in terms of research and development of developing new technologies.
Right. Thank you. Thank you, Praveen.
Welcome, sir.
Very nice presentation. Thank you, Praveen ji, for being with us. Our next presenter is Bharat Sharma ji.